Hey there, welcome to a video discussing section 2.1 on complex numbers. So sorry I can't be here with you this week while I'm on the Kairos retreat. Hopefully you're being nice to your sub. So let's talk about section 2.1, again on complex numbers. And we'll start with the imaginary unit. So if you take the square root of -1, that's defined as I. And I is what we call the imaginary number. So this would imply that I squared would be -1, because if you square both sides of this right here, that's what we would get. So we're going to start with that. Now we'll talk about a complex number. So a complex number is basically more inclusive than real numbers. So a real number can actually be considered a complex number as well. Let me explain what a complex number is. It's basically a real number, which we'll call A, and an imaginary number, which we'll call BI. So the combination of those two is a complex number. So again, it involves real numbers and imaginary numbers, and together we call that a complex number. So 4, for example, is a complex number, believe it or not. It just doesn't have the imaginary part. A is 4, B is 0. 2 plus 3i is also a complex number. Its real component is 2. Its imaginary component is 3. So you can think of complex numbers as being having an identity crisis, if that makes sense. It's real, but it's imaginary. It doesn't know what's true or not. What's fake or not fake. So anyway, that's what's called a complex number. So it's got a real number with an imaginary number, or it could just be a real number by itself, or it could be an imaginary number by itself, like 2i, a is 0, and b is 2. So it's more encompassing or more inclusive than just real numbers. So that's actually true at the top of the food chain of the numbers that we've talked about at the beginning of the year. So let's talk about writing these in standard form. So standard form would imply that you want a real number plus an imaginary number. So it should be pretty easy. That's just 6 minus 2i. Root 4 we know is 2, but because there's a negative underneath the radical, it's going to be 2i. Also, the fact that 2i times 2i is 4i squared, which is, of course, -4. So it would make sense. Square root of -4 is just 2i. And we also have the minus from earlier on, so we have to stick with that. If we go again, we get -7. Now, in this case, it's going to be root 100. That's kind of interesting. So once it becomes just -7 plus 10, that is kind of interesting because you could also think of it as -7 plus 2i, or plus I root 2 times I root 50. So I'm a little bit torn about this one, to be honest with you, because I squared is -1 and root 100 is 10. So is it -7 plus or -7 minus 10? I'll have to get back to you on that because that one's a little funky. But I wouldn't fault you if you approach it either way because you are correct. Now, for equality of complex numbers, what's meant by this is we're going to be combining complex numbers. So let's say we have a plus bi and plus c plus di. That would just be a plus c as your imaginary part and plus b plus di as the imaginary part. So basically it's like combining like terms. Or say if a plus bi minus c plus di. It'd be a minus c is your real part plus b minus d I, your imaginary part. Then let's say if a plus bi and c plus di. And again, if you haven't noticed, c plus di is just another way I'm expressing a complex number. In this case, you want to FOIL. So it's ac plus ADI plus CDI, then plus BDI squared, which of course becomes negative BD, because I squared is negative 1. You have ADI plus CDI. So it's AC minus BD is their real part, and AD plus CD, I is imaginary part. Now it is a bit abstract, so let's actually try doing this in action here. Again, combine like terms. So you get negative 2 minus 15i. Pretty easy. Just subtract the 5 and 7, negative 11i, 4i. Or down here, it's 2 plus 4i. And by 2 to the minus, this can be a plus 3. And that we should know is 3i, by the way, because it's root negative 9. So 3i squared is, we square 3 and the I becomes negative 9. So that's going to be a plus 3i. So that's 5 plus 7i. Oh, oops. Forgot to do with the minus there. My apologies. There should be a minus for that. So actually, that's, I take it back. That'll be 5 plus I. Nope. Yes, no, 5 plus I. There we go. For B and D, this will involve distribution or foiling to get 10i plus 15i squared. So it's negative 15 plus 10i. Over down below, if you FOIL 4 and 2, 4 and 3i, negative 3i and 2, negative 3i, 3i, so you get 8 minus 6i plus 12i minus 9i squared. If you work it all out, you get 17 plus 6i. Remember, that's going to be positive 9 because the I squared is negative 1, the negative makes it positive. And again, you're combining like terms. You could actually test these out in the calculator. I don't have the TI-84 calculator app, but if you hit second and decimal point, you can locate I in the calculator. And you can actually test these out and see if you get the same answers. Okay, so we got just a few more examples to do here. Okay, so we got example 4 here. Before we do example 4, I do see a box that talks about the complex conjugate. Just so you know, if you have a plus b as a complex number, its conjugate is just considered a minus bi. Switch the sign. And that'll play a role a little later. Well, actually, it plays a role right now. So find the complex conjugates, negative 3 plus 2i, or 4 minus I. Now, if you don't see an imaginary number, then that's just straight up just 5. Or if you see 3i, then it's negative 3i. So you switch the sign of the imaginary number within the complex number. That's the conjugate. So now we'll use it for division. What you want to do is multiply numerator and denominator by the conjugate of the denominator. Very important. Because what we're trying to do here is express examples 5 and 6 in standard form. Remember, standard form is a plus bi. You just want a real number plus an imaginary number. I don't have that for examples 5 and 6. Example 5, I have a 5 plus I. Great, but divide by 3 minus I. Altogether, that's not standard form. It's not just a real number plus an imaginary number. It's actually a real number plus imaginary number divided by another real number minus an imaginary number. And example 6 is real number plus imaginary number divided by imaginary number. I don't want that either. So what do? As I mentioned, we multiply both top and bottom by the conjugate of the bottom, or the denominator. By doing that, we can do a little foiling. That's 15 plus 3i plus 5i plus I squared. And down below we have 9 minus 3i plus 3i minus I squared. So if we keep going, you get 14 plus 8i. Remember, I squared is negative 1. And then those cancel. And right now in the room, we have Melina and Gabby. You want to say hi in the video? So this is the video for you guys today, anyway, or later this week. So you got 14 plus 8i over 10. Remember, I squared is negative 1, right? I squared is negative 1. So 9 minus negative 1 becomes 10. And if you work it out, that's going to be 7/5 plus 4/5. So you can reduce each one. 14 over 10 is 7/5, 8 over 10. You got to do the both, though. See, that's a plus b form. You know the real part's 7/5. You know the imaginary part's 4/5. And by the way, you do this in the calculator. If you go second decimal point, it will actually work it out for you. Let's see actually if we try doing some Desmos. I'm kind of curious if we do have an imaginary feature here. And don't know if I see that anywhere here. So I use the TI calculator. Second decimal point is the imaginary number, and you can actually type it in and see what happens. If I do try doing like a negative number, yeah, it's just weird. So I'm not going to worry about it. So let's come back here again. Now in this case, you could just do you could do negative I if you want, or you could just do I straight up, because you're just going to get I squared at the bottom, which I know is negative 1. You got 3i minus 1 over negative 1, negative 3i plus 1, or 1 minus 3i, however you want to write it. I don't really care. Usually we write the real number first, imaginary number second. We got 2 more examples to get through. If you want to pause the video and try this on your own, see if you get the same thing as I do. So let's see, 14 plus 8i plus 35i plus 20i squared, 4 minus 25i squared. Remember, when you FOIL the 2 minus 5i, 2 plus 5i, the outer and inner terms are going to be going to cancel out because you get negative 10i and positive 10i. Those cancel out. So you should get negative 6, because that's negative 20 right there, plus 43i over 29. Negative 6 over 29 plus 43 over 29i. Then we ended off with solving an equation problem. Now, if you were to graph this, by the way, and actually we can use Desmos now, and we're going to make the connection to the algebraic and the graphical. So 2x squared, so y equals 2x squared minus 5x plus 7. Hey, that never touches the x-axis. No x-intercepts. Y doesn't equal 0. Do quad form, you're probably going to get something that's going to indicate no solution or imaginary answers. See, we're going to do our quad form here. This is not factorable, by the way. So negative 5 plus or minus 25 minus 4 times 2 times 7 over 2 times 2. That's 5 plus or minus. I don't know why I keep getting Dropbox updates. Let's get rid of that. And then you're going to get 25 minus 56. Ooh, look at that. We keep going. I think I'm doing this correctly. Yeah. 5 plus or minus root negative 31 over 4. I do want to simplify if you can, but I don't think we can. But we'll pull out the I. And in standard form, it's 5/4 plus or minus root 31 over 4i. So now we can see that, okay, this had no x-intercepts, so the answer should be imaginary. And that concludes the video.